Hi everyone. Today we will go over some topics in geometry. First, we will look at some examples involving the ruler postulate and absolute value. The ruler postulate just says that the distance between 2 points A and B on a number line is the absolute value of the difference of the two numbers. So let's do a couple of examples. Doing that here, we get 9 as the distance between -6 and 3. Note that it doesn't matter which way we do this, since we are taking the absolute value of their differences. Next example, we do the same process as above. Just take the absolute value of the difference between the two numbers. Now, let's do some examples that involve some algebra. For this example, we want to find out what x is. This can help with the other problems as well. First, we know the length of segment AM plus the length of segment MB is equal to the distance between -6 and 21. We can simplify both sides of the equation then get x by itself by dividing both sides by 9, and we get x is 3. To find the length of segment AM, we simply plug in 3 for x. So we end up with 9 being the length of segment AM. MB is 6 times x, so again, plug in 3 to get the length being 18. To find the length of segment AB, we just take the absolute value of the difference of the two numbers, -6 and 21. Notice we actually did this already in part A. to find the value of m, we can add 9 to negative 6, or we can subtract 18 from 21. Another example. Similar to the last example, we want to solve for x. We can do this by setting up the equation where the segment AM plus the segment MB add up to the distance between the 2 points, negative 19 and 30. Now we simplify a little to see what to do next. We see that this ends up being a quadratic equation, and we can solve either by factoring or using the quadratic formula. Either way, we get the equation in standard form by moving everything to one side and having 0 on the other side. This example looks like we can factor by looking at factors of the constant term that add up to the middle term's coefficient. We then set x plus 9 and x minus 5 equal to 0 and solve both equations for x. We get two solutions, x equals negative 9 and x equals 5. But only x equals 5 makes sense, since x equals negative 9 will give answers that don't make sense. Now we can use this result to help with the next parts. For the segment AM, we plug in 5 for x and evaluate to get 10. Now let's find the length of MB and plug in 5 for x there. Evaluating, we see that we get 39 as the length for the segment MB. To find the length of segment AB, we just find the difference between negative 19 and 30, which we did in part A. To find the value of m, we can either add 10 to negative 19 or subtract 39 from 30. Now we will look at some problems involving lines and angles. Note some definitions and terms on the left. In this example, B is the midpoint of A and C. This means that the segments AB and BC are the same length. We denote this by writing a line in between each segment. Since segment AB and segment BC are equal, we can set the two expressions that they both correspond to equal to each other. Now we can solve for x by isolating it on one side of the equation. So subtract x on both sides. Then add 10 to both sides. Divide both sides by 4, and we get x equals 3. To find the length of segment AB, we just plug in 3 and evaluate. And since B was the midpoint, AB and BC are equal, so segments AB and BC are equal to 5. To find the lengths of AC, we just add AB and BC to get a length of 10. Another example. Again, like the previous example, B is the midpoint of A and C. So the segments AB and BC are equal in length. Now we can set their corresponding expressions equal to each other. Here we have a quadratic equation, so we can solve by getting it in standard form and factoring. This is a difference of squares, so we can factor it as x plus 3 times x minus 3. Setting both equal to 0 and solving both equations, we get x equals negative 3 and x equals 3. X equal to 3 is the only one that makes sense here. Now we just plug in 3 to get the length of AB. Evaluating, we get that 21 as the length. Also, remember that AB is equal to BC, since B is the midpoint of AC, but we can verify it anyways. To find the length of segment AC, we just add up AB and BC. We get that the length of segment AC is 42. Now let's look at an example where a segment bisects two segments or rays. In this example, the segment BC bisects the angle ABD. So this creates two equal angles in between angle ABD, angle CBA, and angle DBC. Let's say for this example that the angle CBA is equal to 7x plus 4 degrees and angle CBD is equal to 6x plus 8 degrees. Since segment or ray BC bisects ABD, then CBA is equal to CBD, and we can set their corresponding expressions equal. Then we solve for x by isolating the variable. We end up with x being equal to 4. Angle CBA is equal to 7x plus 4. So we simply plug x equals 4 into the expression and evaluate to get 32 degrees. We can do a similar plug-in with angle DBC, or just recall that angle DBC is equal to angle CBA. To find the measure of angle ABD, we add the angles CBA and DBC together to get 64 degrees. Another example, segment BC bisects ABD, so angle ABC is equal to angle CBD. To solve for x, we can set the two corresponding expressions equal to each other. Then we isolate x to solve. After a little work, we get x equals 16. To find the measure of ABC, we plug in 16 and evaluate. We end up with angle ABC being equal to 88 degrees. This is also the same as angle CBD, but we can still plug in x to verify. To find the measure of angle ABD, we add up ABC and angle CBD to get 176 degrees. Moving forward, let us go over the midpoint formula. In a nutshell, the midpoint is just averaging two values to wind up in the middle of a segment, as you may notice with the formula on the left. Doing a couple of examples, you can see that to get the midpoint, we just add the two x values and divide by 2. And we repeat with the y values. So the midpoint here is -1, 3/2. A cool way to check this is by looking on a graphing calculator to verify this. I like Desmos.com. It's cool and free. So we just input our endpoints and our midpoint to see that indeed it is in the middle. In this next example, we do the same thing as the previous example. Average the x and y values to get the midpoint. we end up with 2, -4 as the midpoint. Now let's double check with Desmos. Does it look like it's in the middle? Now let's do an example given a midpoint and an endpoint. We want to find out what A is, so let's mark that as X, Y. And also, let's make note of the endpoint B. Now we can set the midpoint formula equal to the actual midpoint, 1, 0. Then we can solve for each value of A, which is X and Y. Now let's plug in our known values for endpoint B. Now we can set the X part equal to the X value of the midpoint, which is 1. And we can set the Y part equal to the Y value of the midpoint, which is 0. Then we can solve each equation for its corresponding variable X and Y. For X, we get -3. For Y, we get 3. So the endpoint A is at -3, 3. Let's check this on Desmos. Let's clear it real quick. Now input our values to verify it looks right. Looks good.